Hello everyone, my name is Ketan Shende and for my MAE 513 project I have analyzed the quick return mechanism. This mechanism is used in shaping tools to convert the rotary motion of the crank into the reciprocating motion. So as you can see in this video, this is a shaping tool wherein the quick return mechanism is used for cutting the workpiece. In this mechanism, the angle of advance and the angle of return determine the quick return ratio. In the analytical model, I simulated the mechanism and constrained it using the geometric parameters. So as you can see over here in the videos, based on the radius of the crank arm, the displacement of the slider as well as the velocity with which it moves changes. This is also reflected in the performance curves, which we can see over here. So as expected, in the acceleration graph there is a sudden peak which corresponds to the drop in the velocity. Along with the analytical model, I also used the constraint relaxation method to simulate this mechanism. So the development of the constraint relaxation model, while modeling the crank was relatively easy, modeling the slider on the rocker arm was particularly difficult. This is because the length of the arm changes for each angle of the rocker. So as we can see over here, the entire model is constrained. There are two ways in which I constrain the slider at the top to move horizontally. One way was by hard coding it to move horizontally, while in the other method I used vertical springs to restrict its motion. So as we can see, where the vertical springs are concerned, it tries to move along the horizontal direction with an oscillation in the vertical direction, whereas when it's hard coded to move horizontally, the slider moves horizontally but the connection of the link with the rocker arm is affected. So this was my project on the analysis of the quick return mechanism. Thank you.